So good morning, everyone. My name is Vivek Singh, and I'm a senior solution engineer for Niagara Networks, joining from San Jose, California. With me today is Alan and Anthony from Telchemy. Introduction.
So hi, this is Alan Clark. I'm the CEO and founder of Telchemy, based in Alpharetta, Georgia.
And this is Anthony Caiozo, National Sales Director here in Massachusetts.
Thank you, Anthony and Alan. And we are in this webinar going to discuss about Niagara and its product line, as well as Telchemy and its product line. And then we are going to talk about the joint solution between Niagara and Telchemy and what are the value propositions which we are providing to the customer, specifically in the visibility area of VoIP applications. So moving on to the next slide. So Niagara Network is a leading network visibility solution provider. We are based out of San Jose, California. When we talk about network visibility from the holistic point of view, it broadly consists of two parts: aggregation and filtration of the network traffic, and the analyzation of the network traffic to understand what is happening in the network. So Niagara Networks only concentrates on the first part, that is packet acquisition and traffic filtration. We leave the second part, the analyzation part, to our many technical partners, for example, Telchemy today. A common question which has been asked to me numerous amount of time is how Niagara Network is different as compared to its competitor. Well, to start with, we manufacture all our products right here in USA. We have a great control over quality and lead time. We provide same functionalities and performance at a much, much better price range. And the reason behind it, because of our sister company called Interface Master, which is also present in Fremont, California. Interface Master is an OEM company, has been manufacturing industry standard products for Cisco and Broadcom. Many of our competitors, even today, buy directly from Interface Masters and later rebrand it. So that gives Niagara a unique position to maintain its cost and quality. Now, a little bit about customers. We have a global customer presence. Our products are implemented into finance, technical, enterprises, health sector, education, and the response which we get from our customers are the product are easy to implement, highly reliable, scalable, great support, and lots of advanced features. So that's my 2 cents about Niagara Networks. Moving on, our products are divided into 4 categories. We have passive and active taps for tapping into copper and fiber links of all speed and types. We also provide software called virtual cloud taps to tap the traffic into private and public cloud infrastructures like AWS, Azure, GCP, etc. And then we have Network Packet Broker, which is a hardware device for on-prem solution, as well as a software machine that's called Cloud Packet Broker for aggregating the traffic into public and private cloud infrastructure. We also provide inline network bypass switches for providing security and redundancy to network links in case any of the inline appliances like firewall, WAF, or DDoS fails. And last but not the least, we have centralized management system for configuring and managing all our devices from one platform. So handing it over to Alan for introduction of Telchemy and its product.
Thanks, Vivek. So Telchemy is a software company. We were established in 1999, so we've been doing this for a while. We're based in Alpharetta, Georgia, and our products are sold internationally. So we focus on doing analytics software for largely for unified communications, but also for network services and network applications. And as with Niagara, our products are 100% made in the USA, so all of our software is developed in-house in Alpharetta. We have strong reference customers. We have tier 1 service providers, large enterprises and government customers. And also a substantial amount of our business is through OEM and software licensing. So we also have a large population of customers who are network and telecom equipment manufacturers and test equipment manufacturers. So you're very likely to be using Telchemy technology somewhere in something. So we provide a real-time visibility of network and application performance through active and passive monitoring. So we have a highly scalable performance management system called SQ Mediator. And what we mean by scalable is something that can handle anywhere from a few hundred endpoints all the way to millions of endpoints. And as I mentioned, tier one service provider volumes of traffic. We have high capacity voice and video conferencing probes that can be deployed either on hardware platforms or deployed in VMs or in the cloud. And by high capacity, we mean up to 10 to 20 gigabits per second. Then we have active test agents, which are able to do synthetic transactions. And these can be deployed on small devices, such as Chromebooks or Android phones, and through to high capacity systems based on Linux servers. And again, these can be deployed in either on hardware platforms or deployed in the cloud. And then we provide embedded voice over IP and video analytics that gets deployed in chipsets, client devices, high performance systems, including routers and other manufacturers' probes and analyzers and chipsets. So over to you, Vivek.
Thank you, Alan. Let's move on to the next slide here, which is elephant in the room, encryption. Encryption is certainly a blessing for protecting end customers' confidential data, but at the same time, it provides quite a challenge for the security operations team. The challenge can be classified broadly into two parts, the security challenges as well as the implementation challenges. So let's talk about the security challenges. About 80% of the enterprise traffic is encrypted, about 70% of the public cloud traffic is encrypted. All these stats give a false sense of security because in the recent years, encryption has become a vector for delivering malware data into the enterprise networks. For example, last year, about 80% of the detected malware was encrypted. And one of the reasons behind it is because of the emergence of the low cost and free HTTPS certificate providers, which make even scamming and phishing website looks legitimate. So visibility into the encryption is of paramount importance for network security enterprises. Now, moving on to implementation, some of the factors which needs to be considered are what will be the cost of implementing visibility solution? How easy will it to integrate the visibility solution with the existing network security tools? And certainly in case of runtime application, for example, VoIP services, we need to also consider what will be the latency provided into the network. So I think a perfect solution will be the one which is aiming to increase the security postures of the enterprises, but at the same time, decreasing the implementation challenges. And that's what Niagara and Telchemy joint solution aims for. Helen, over your thoughts on encryption and specifically encryption challenges in unified communications?
Yeah, thanks, Vivek. I totally agree with what you're saying, that one of the biggest challenges, not just the SecOps teams, but also NetOps teams. Very often when traffic is encrypted, then you tend to lose visibility of the performance information that's latent in the traffic that you would like to analyze, and that can present significant problems in understanding, what's being sent, who's it being sent between, and what are the performance characteristics of it.
Thank you, Evan. And what do you think about the challenges for the unified communication and how is Telchemy solving it?
So in the case of unified communications, then we tend to see encryption in two areas. One is the encryption of the signaling traffic, so the SIP signaling protocol being sent over TLS. And the second one is secure RTP or SRTP, where the media stream itself is encrypted. Now, Telchemy's technology is actually able to analyze SRTP without decryption, so we can still obtain performance information from encrypted voice and video streams without having to decrypt it. The problem we face is that the signaling information identifies who the end users are. So without the ability to decrypt SIP over TLS, we can say, oh, this call was good or this call was bad, but we can't say, and the call was between A and B, because the A and B are encrypted in the SIP over TLS messages. So it's it's a little difficult for the network manager, the telecom manager, to know that there are problems without knowing who they affected. So hence a joint solution that's able to decrypt the SIP over TLS and complement our ability to analyze encrypted SRTP is a definite plus.
Thank you, Alan, for your insight. So moving on to the next slide, this is an overview of Niagara implementation into a customer site. As you can see, they are a mobile operator providing a host of different VoIP services. And some of the customer requirements were decryption of TLS 1.2 and 1.3 traffic, ability to handle wildcard certificate, decryption of the SIP signaling between Oracle, SBC, and clients. Niagara provided an advanced packet broker, which was a one-box solution where the decryption part was running within the Packetron, which is Niagara's smart platform, and to handle all these challenges. So, Alan, my question is, once Niagara is going to provide the decrypted traffic, VoIP traffic to the Telchemy, what advantages Telchemy is going to provide to the customers in such kind of scenarios?
Well, it means that the customer can have several different things. They can have again knowledge of who the end parties of the call were, which is essential. But also our probe and management system have the ability to be able to capture the signaling traffic and to store and display it. So that way the network manager or network engineer can see the signaling flow between that made up the various parts of the call, and see the content of the signaling messages, which is extremely useful if you're trying to troubleshoot signaling problems. And so if the SIP's being sent over TLS, then we can't do that. But if with SIP over TLS being decrypted, then it does give us the ability to be able to display all of that wealth of call signaling information.
Thank you, Alan. So before we talk about the Niagara and Telchemy joint solution, we need to understand what is Open Visibility Platform. Open Visibility Platform is a combination of Niagara Packet Broker and Packetron. Niagara Packet Broker comes with basic functionalities of the Packet Broker, for example, aggregation, replication, load balancing, and so on. Packetron can be envisioned as a smart hardware module, which provides added functionalities to the Packet Broker, which can be inserted into the Packet Broker. So some of the added functionalities of the Packetron, once they are inserted into the Packetron, are it can identify duplicate packets, it can do layer 7 application filtering, it can do header stripping, and also it can do TLS decryption ranging from 1.2 to 1.3. In addition to that, Packetron can also host a virtualized platform, for example, VMware or open source XCP server, which can later be used to implement or integrate third-party software, for example, Telchemy SQprobe today. So the combined solution of the Niagara Packet Broker, capability of the Packetron to run advanced functionalities of TLS decryption and host Telchemy SQprobe provide a single box solution for end-to-end network visibility. And that is what we call as an open visibility platform. So now moving on to the next slide here, as we discussed that Packetron can run hypervisor platform. So that the way Telchemy SQprobe has been integrated into Niagara platform is one of the Packetron is running the hypervisor platform, and there the Telchemy SQprobe is running. So Niagara is getting all the traffic from the taps and spans or different tunnels. It's cleaning and sanitizing it with different filters, and then feeding it to the Telchemy SQprobe. So Alan, what will be the advantages, or how the Telchemy SQprobe is going to analyze this traffic and then send it to the centralized platform?
Okay, thanks, Vivek. So essentially, SQprobe is able to detect and analyze individual calls and provide a detailed report on each call, together with a detailed analysis of the signaling flow. In addition to that, it can also on demand capture calls as well, and make packet captures available for live voice and video sessions. So these real-time reports are sent up to SQ Mediator, which can be running in a data center, or it can be installed by the customer in a cloud environment. And so SQ Mediator receives these reports, stores them. If you were seeing the same call at multiple different locations in the network, so let's say you had going through multiple session border controllers and you saw 3 or 4 call legs, then SQprobe can see each of those call legs and send reports on them. A Mediator can correlate them. So that way, from Mediator, you can see the correlated view of the call. You can see all the legs kind of assembled together. And then for each call, it generates, you have the QoE scores, the MOS scores, and degradation factors that were calculated by SQprobe and reported. And then you can do real-time thresholding. So if there are any calls that are outside the required thresholds, then those will be aggregated, and you can generate alerts from them. And there are real-time dashboards that let you see where things are going wrong, click on things, and drill down very quickly. So SQ Mediator gives you the ability to be able to look at current and also historic data. One of the nice things about the system is the fact that it is giving you constant visibility. And so if you heard that there was a problem last Tuesday at 3 o'clock in the afternoon, you could just go back to through using SQ Mediator and look at call quality from that time and see which calls were the problem and which users were affected, and what the likely cause of that was. So
thank you, Alan. And moving on to the joint application value proposition. So consider a hypothetical scenario where a network engineer needs to monitor his network links. What are the steps he needs to perform? He needs to span or tap the traffic. He needs to aggregate the traffic into a network packet broker and then clean and sanitize that traffic to reduce all the noise. And after that, he needs to decrypt the traffic. And in addition to that, he needs to maintain an additional server where he can run Telchemy SQprobe. And the last part will be configuring the Niagara packet broker, Telchemy SQprobe, as well as the additional server. So consider this, all these steps merging into just a one-box solution, which is fully integrated and providing right traffic to the right tool. That's what the value proposition, the joint solution between Niagara and Telchemy is providing. It is a cost-effective solution, easy to implement, comes fully integrated. So now moving on to the next slide, what will be the deployment, what will be the deployment techniques or responsibilities for the customer once they have the joint solution for Niagara and Telchemy. As I said, the packet broker comes fully integrated with the TLS decryptor running in it, and also the Telchemy SQprobe running on the packetrons. So the only steps from the customer side will be to rack and stack a single box solution and provide all the traffic from different sources like passive, active, or virtual tunnels. Once those traffic are received, Niagara is going to do the cleaning and sanitization of that part and then send it to the Telchemy SQprobe so that the analyzation of the VoIP applications can be done. So I think that brings to the end of the webinar. Any closing thoughts, Alan?
No, that was very, very helpful to me, actually. So, and we should say also that the solution is applicable to video conferencing as well as voice over IP. Right.
Okay. Thank you, Alan. That was really beneficial to me also, understanding how the Telchemy can help the customers for VoIP applications and video conferencing, and how Niagara can be beneficial providing decrypted traffic and clean traffic into the Telchemy SQprobe. Thank you very much.
Great. Thank you.